All right, we've been working the last few weeks on functions. What we haven't looked at in detail is how functions and equations go hand in hand, particularly the notation in working with functions. We've worked with equations before where we have one variable y and another variable x. In function world, we are a little bit more explicit with our functions. We label our y value as whatever we want, f or p or whatever letter is descriptive, and then we parenthetically add the independent variable. This is not p times x, this is p depending on the value of x in this way. So let's understand that p of x is itself an inseparable idea. It gives us the name of the function and the name of the independent variable, which will be followed by a rule in itself. Now sometimes we'll even have context, like in this case, p of x represents profit. So p of x is how much money I get to keep in my blanket company. Depending on, it says the number of blankets made in a day. So x represents the number of blankets made in a day. So here's how we use this equation and the language of mathematics to translate into language that most normal people use. In this case, if I use 3 blankets, if I make 3 blankets in a day, then I'm asking for what is p of 3. You can evaluate p of 3 just by putting 3 everywhere there used to be an x. Notice the parentheses. You should then do the number crunching by hand, and eventually you'll get to the point where p of 3 equals $18.25. So this is the mathematical question, this is the mathematical response. Our job is going to be to translate that into an actual question. In this case, p of 3 is asking, what's the daily profit if the company made 3 blankets? I know that because x is 3, which is the number of blankets, and that x has been replaced by 3. I know p is unknown, p stands for profit. So what is the profit for 3 blankets made? Now to answer the question, the answer is $18.25, and so I answer that. The company would make $18.25 in profit if they made only 3 blankets in a day. You can change the form of the question by revealing something about the dependent variable. In this case, what if I profited $52? How many blankets, I was going to say shirts, how many blankets could I make in order to profit $52? What I'm asking essentially is, p of x equals 52 is asking if y is 52, what value or values of x will make that profit happen? Now there are varying ways of solving this equation, and we're going to learn that in more detail this year. For right now, it should be sufficient to say that x equals 8 or x equals 12. What that means, which is weird, there's 2 solutions, but that means if I made 8 blankets in a day, I would have $52, or if I made 12 blankets in a day, I would have $52 in profit. There are reasons why there are 2 solutions, and that's another thing we're going to explore this year. But for now, the focus is on the notation and interpretation. So just as in the last example, I have the question stated in mathematics form, all of this in black, and I have the answer stated in mathematics form, p of 8 equals $52 or p of 12 equals $52, showing x is 12 or x is 8. That's the mathematics. The English is, the question is asking how many blankets would need to make a $52 profit for the day. The answer is, to get $52 in profit, either make 8 or 12 blankets. Now there's more you can do, and we're going to learn that later this year, but for now, this will be sufficient. Some more examples exist in the text that are given to you on the website and by hand. And what I'd like to do now is just to give you some examples of the work that's on these particular questions. So I have a generic function that has no context. I have a function that's talking about height over time, and this one is talking about voltage over time. And I have various kinds of questions that are asked in mathematics language, and I wanted to show you how to write out your responses and how to interpret your results. And so that's what follows. In the first case, we have the function f of x equals 3x plus 20, and I'm asking about f of negative 4. So in order to find or evaluate f of negative 4, and evaluate is the right term, when x is negative 4, everywhere I saw an x, I replace it with negative 4. Remember, this is not f times negative 4. This is what is the value of function when x is negative 4. And here's how I find out. 3 times negative 4 is negative 12. Negative 12 plus 20 is 8. So f of negative 4 is 8. Now, there is no context, but what I can do is interpret the result as negative 4, 8 is a solution to f of x, the equation. This equation has 2 unknowns, f of x and x. If one of the unknowns, x, was negative 4, then the other unknown, f of x, would be equal to 8. That makes a true statement, therefore a solution to this equation. So that's just a simple sentence to say, this is what my result means. So similarly, if f of x was replaced with f of 10, then now I know x is 10, and I find f of 10 is equal to 50. So I simply state that 1050 is a solution to the equation. I wonder what would happen if I plotted all of the solutions to this equation on a graph. I wonder what the graph would look like if I showed every one. And now there's infinite solutions because I could pick anything I want for x. But I wonder what would happen if I took every single one of these solutions and put it on a graph. Anyway, I digress. Here is a different kind of question than this. Here, x has been replaced with 10. Here, x is unknown, but the y value, or f of x value, is 38. So that's a different kind of question. We need to get used to this notation. If the question is f of x equals 38, this is the implies area, which means implies or means that. So if f of x is equal to 38, that means that 38 is equal to 3x plus 20. Notice that 3x plus 20 is f of x. So if f of x is 38, then 3x plus 20 is 38. This is a simple linear equation that I solve and find f of 6 equals 38, which means 38 is the solution to f of x. So I solve the equation, I find the value of x, I make a function statement of truth, and translate that into common sense. Quickly go through this example just so you can see what the writing should look like. H of 2 is really straightforward, but the point I wanted to make here is t exists in two different places in the function. Don't forget to substitute all values of t with the new substituted value, in this case 2. So we have 2 times 50, then we have 2 squared times 4.9. Don't forget to square first, that's the order of operations, then multiply by 4.9. And that gives us that result. Now the difference here is this is now in context. T represents time in seconds, and h of t represents the height of the object. So h of 2 is 80.4 feet. I'm not just going to say that's a solution to the equation. I'm going to translate that. In 2 seconds, the object is 80.4 feet up, pointing out this is a solution to the given equation. So we can do the same thing for h of 5. And I will state again that in 5 seconds the object is 127.5. I said meters, but I meant feet up in the air. So we're higher after 5 seconds than we were after 2 seconds. And the other question is different, though. It's saying, look, if the height is 0, what that means is if the height of the object is on the ground, then what time was the object on the ground? We can use common sense here. We can obviously see that when t equals 0, this is all going to equal 0, which means the object started on the ground. That makes sense. But if the object is launched into the air, it's probably going to come back down again, so there has to be another solution. Don't worry, you're not going to be tested on this right away, but this is the way you do it. You factor out the common factor of t, and then God said I could separate these into 2 different equations, and so I do. I get t equals 0, which we already knew, and then I could solve this equation using basic algebra to find that t is more than 10, so about 10.20 seconds. So the object is at ground level. I'm translating into English now. When it's launched, and again 10.2 seconds later when it lands. So this would represent the kind of parabola that this function is shooting for, and 10.2 seconds in. Not that this is a good graph, but I already used words here, so I'm just illustrating what I'm trying to accomplish with my paragraph. Last but not least, this is no problem here. Just recognize that the variable t is an exponent, so you have to take 1.02 to the 4th power to get that number, and then since it's my heater just blew up. Now, I have the is a solution to, but I also have in context. In 4 seconds, there will be 10.92 volts in the circuit. But B is what I wanted to talk to you guys about, because I want everybody to understand that C plus 10 is an algebraic way of expressing a general form. That is, I want to input something that's 10 bigger than some unknown value and see what happens. So don't be intimidated by the fact that there are unknowns that are being substituted in for other unknowns. That's just the way we do, and you'll see why later on. But in this case, I want everybody to feel comfortable with substituting unknowns for unknowns. So what used to be unknown was time. Time has been substituted in as C plus 10, which means I'm going to have 3 times C plus 10 minus 1.02 to the C plus 10. Now, most people are obsessed. They feel like they have to make steps. They have to do some algebra. The only thing I can do is distribute the 3 here. The rest of this is simplified as much as I can get. Now, why do we ever have to do that? We'll get to that later. But right now, just get comfortable with the way that the notation works. That's the whole purpose of these exercises. So what I'd like everybody to be able to do over the next 3 days until we meet again as a class is in your handouts or your packet, you'll see these three problems, and I have to look real quick somewhere. That's on page 17 in your handouts currently. That may change. And this is the rest of 17. You'll find this on 18. And there are more questions that follow, all the way to the end of page 19. That's plenty of stuff to do. You'll have a chance to do some of this in class, and you don't necessarily have to do every single problem, but you should definitely explore and look for challenges. So, enjoy.